What were you trying to make? Join us as soon as it was done. I was trying to rebase some old code to work on the newest version. Um, it's somewhat complicated. It's part of a physics engine. I'll load this map up again because it helps with the visualization. So I'm making this game. This is a big surf, and the hard part for the physics engine is the fact that you need to sit nuzzled in the bottom of this surf, like this. And so it has to do linear algebra to determine where you sit without intersecting anything, and like which directions you're allowed to move, because there's like a limited range of motion when you're sitting there. And this push solve algorithm does that. It determines if you're moving down in this, then you have to move forward instead. And it works for any number of surfaces, any set. That's the contexts input here. And then it gives you the output. So it like takes, so this can be a velocity or an acceleration or a position. It's general across those, and it will constrain it to the contact normals and give you some output. Maybe it fails. And it was designed by my friend Trey, and written in Lua. Where is it? Oh, it's right over here. So this is the original algorithm. It was using indices. It was indexing the table, the Lua table, and like shifting around indices here. So it would like try different indices and stuff. And it had some like questionable types, and it was like passing around nil values and stuff. So I made it strongly typed, first of all, and I also made it only pass around references. So I have this cons list, and it's where is it? Oh no. It's an array vec. So it's an array. Okay, it says right here. It's an array backed vector, fixed size array. So it's up to 4. The original algorithm never used more than 4 points of contact, because that's all you need to fully constrain all movement. So if you're blocked from, if you imagine a tetrahedron blocking you on all sides, you can't move in any direction. That you need 4 surfaces to completely block motion. And then more surfaces doesn't matter after that. So it's a list of references to contacts, and it manipulates this list of references instead of manipulating indices onto some other list, which I am quite proud of. So it's like shuffling. Where does it do the shuffling? Ugh. Const as slice 0, 1, 2, 3. Push. Yes. Okay, it's pushing onto the front. So this pushes on to the end. Wait. I'm confusion. What is this? I mean, it obviously works, but what is going on? It's, I think it's supposed to push onto the front. Oh, do I have them in reverse? I think I don't know. I wrote this what 5 months ago. Wow. So I don't really remember. I had the algorithm in my head at that time, but yeah, I really tried to like rustify it and like make it strongly typed. Use optional values instead of nil. Well, you have to, but try to like do like static dispatch sort of thing. I guess I'm not really doing static dispatch. I'm just like matching against the length of the list. Oh, here it is. Here's the shuffling. So inside this, it's like, is space enclosed? Are you blocked in from all sides? Or wait. I don't remember. Minus. It's like is the determinant a negative number or something like that? 4. Yeah, there's a whole lot going on. Anyways, complicated algorithm. It does the thing. And it's very rustified from the original Lua code, and is very pleasing. And the code was problematic when I wrote it 5 months ago. What would happen is if I jumped and then I moved the mouse, you would fall through the ground just like that. And that's a bug on surfs as well. So if I move the mouse while doing this, I'll just like fall through, and it'll be bumpy, and like so yeah. So I'm like clipping into each one if I'm moving the mouse, but if I don't move the mouse, I just slide fine. So like I can slide on the surface fine, and I just fall down there, and it's perfectly smooth. And I was hoping that I could extract I see it doesn't return that. I was hoping I could extract which contacts were used to constrain the surface to prevent those contacts from being removed which is why you're falling inside of it. It's because it's like, oh, you're moving away from this at 0.0001 units per second, so you must not be touching it anymore, but you still are. All the complicated stuff is to push the player away from something. No. This is totally different from any other physics engine. So most physics engines are like iterative, and they correct the iterations. So like you're kind of just moving along, and you check, am I inside anything? Game tick. Am I inside anything? Game tick. Am I inside anything? Oh, I'm clipping inside the microphone. All right, so well, if I move out this way a bit, then it's no longer clipping. And it sort of corrects every single frame. That's not how this works. With this physics engine, I am tracing the mesh through space. And so there's no game ticks. It just has a deadline. It's like, or a time limit rather. It's like, find anything that happens within 100 milliseconds. And it will use the hitbox to trace out a region, or like construct a region based on the path that the hitbox travels through, locate objects that intersect with that region, test collision against each of those objects, and then return the first one that touches. So it can never miss. You can't be going so fast that you just teleport to the other side of something and you've clipped through the wall. It doesn't happen because it traces the path volume. It's predicting what's going to happen. The physics engine is predictive and not corrective. And there's also no game ticks. It's things just kind of happen with timestamps whenever they happen. There's no like the world moves in lockstep. The world does change in lockstep, but that's every single atomic update. I've put a lot of time into this. I'm really happy with my ideas and stuff. This is like 9 months of work on this engine probably now. But I've made this game twice already. So these are like my best ideas put forward into code. There's a lot going on. I would very much. Ooh. I think if I jump, it won't happen. Wow. Okay. Can I go into this corner? Okay, I think what happened there was no game tech seems like a double-edged sword. It is very I have to be cognizant of the game design at all moments. It's extremely error prone. I guess the no game tech's not so much. It's the game is designed as atomic state updates with analytic state continuation. So if I touch nothing, it does no work. It only renders the analytic state continuation of the last input until you hit something. It's actually doing parabolic mesh tracing as well. I really have a lot of work in this. So from the moment I stop pressing keys, it has formed a parabola. I can show you in the code. Body. It's right here. So this is what represents the player object. I know what all those words mean. So you have a position, velocity, and acceleration. That's a parabola, right? And a timestamp of when to start from, how to extrapolate it. So you get the extrapolated position. So the moment you stop pressing keys, it's just displaying the extrapolated position from that parabola as long as there are no internal game events, such as hitting a wall. So that is at the top of here. This is so here's a generic physics instruction. Either it's internal, so it's a collision starts, a collision ends. There's a strafe tick. This is the only thing with a fixed tick rate. Or you've reached your walk target velocity. So the walk target velocity is like you reach the top speed of walking. I can just demonstrate it. So like you can see you like accelerate and then you reach a top speed. So reach walk target. Actually, you could probably see it here. Oh no, it's silent. Never mind. It happens when you reach the top speed and also when you reach zero speed. That's reach walk target velocity, and that's an internal physics event. How it works is the physics is asked what happens next, and if it doesn't say something happens before the input, then it runs the input. Where is this? Physics, run input instruction, do it. Yeah, okay, so this is like how the game works. So you have an input instruction here, and then it runs any internal instructions exhaustively. This is like the main loop. So next instruction, the physics asks itself what happens next. So this is like, I'm an instruction emitter. I emit a internal instruction. And I'm also an instruction consumer. I can process a physics instruction. And notice these types are different. This is the like generic physics instruction. Maybe it's internal, maybe it's external. But this is internal only. It'll only emit an internal instruction. It won't emit an input instruction, which is like you press the W key or something. Or maybe it should. I don't know. And then, so this is, do you know Rust? See the function signature here. There's no mutable variables. So it does not mutate any state. It's merely asking what happens next, and it doesn't change any state. Whereas the process instruction is like performing the instruction, doing the action. So if we look in here, instruction idle, internal instruction. Okay, well, let's look at the input ones. So, okay, well then there's this big mess here as well. Untab. Yeah, okay, well you can see like for each input, like maybe you press move forwards, it's just setting the control and then it like refreshes the walk target. I don't know Rust, but I know mutable, immutable. Yeah, I love the control over that. These function signatures are awful. I don't know how to do this. But like teleporting somewhere actually might change all of this stuff. So like the move state, well, maybe you go from being on the ground walking to being in the air because you teleported somewhere. The body, obviously you're teleporting somewhere that changes the position of the body. Touching, well, you're no longer touching the stuff where you were before. You're somewhere else. You aren't touching those things anymore. The run state, that can get updated because maybe you teleport into the finish zone or something. So you finish the run. The run is like, it's a speed run game, right? So you start at the start and you finish at the finish. And the goal is to get the fastest time. Mode state is what stage are you on? So you start on stage 1 and then you reach stage 2. And if you fall into a trigger, you teleport back to the start of the stage. But if you fall into a trigger that's on a previous stage, you shouldn't lose progress. You should go to the most recent checkpoint. So that's the mode state. It remembers what checkpoint you're on and various other things like, well, I call them spawns and stages, but checkpoints, you have to touch all the checkpoints before you're allowed to reach the next stage. And then there's also a limit on jump count for a particular mod. There's lots of stuff. And then immutable values, it needs to reference things in various states. So like it looks like surely you don't need all this, right? But you're teleporting somewhere else. It really does need to change all of this stuff and like reference all of this data. And this is of course wrapped into larger data structures, but some of the things need to be mutable and some of them need to be immutable. So like it needs to split the data structure and say these ones are mutable, these ones are immutable. And the only way I figured out how to do that is to split it all up like this. Because like if we look at the physics state, boy. So you see this is like those like runtime state on each step, which can happen at any time. And then this is sort of like immutable-ish data. It's just like, where are things in the map? What models are there in the map? What modes exist on this map? Cache of the mesh. It's like stuff that doesn't change unless the map changes or like you change style, kind of. So it's like less. It's not. It's always immutable on instruction atomic state updates, but it might change for like the map changing or something, or some other like rare event. But yeah, as you can see, there's a lot of code, and it is very messy. I love talking about this. My specific choices and how the game works. Bruh. Okay, what can I do? Let's see. Okay, so I was surprised that the push solve code went into the game without a hitch, because 5 months ago it was causing problems. So what I've done within the past 5 months is write a new way of doing math, a math library. Here I go, another tangent, another like choice game design thing. What visualization tools you're working on today? The hope is to have a tool where I can watch a collision detection event happen. What's a map? Ice. I don't remember what it's called. There's. I'll just run Arcane. So on this map, there is. It's in the tree area. So generally the I keep hitting the wrong stuff. Generally the axis aligned platforms work. But then the oblique stuff is less guaranteed to function properly. I'm just gonna go. There's some invisible walls there. So okay, so like these, you see they're oblique. Let's see if I can hit a case. No. Sometimes you can like just kind of fall through the edge, and that's kind of the bug I'm trying to. Oh. Is that a different bug? So there's also a walking bug. I can't hit it, man. There is a case where the physics fails, and you like, I think it's like this, no? And you'll like clip through the platform without hitting it. And it's like a failure case of the oblique meaning off grid. Yes, non-axis aligned. There's a failure case. So the collision detection algorithm, where is it? Who did this? What the hell? It's in model physics. So the collision is using Minkowski sums of convex meshes. And it's tracing a parabola onto the surface of the Minkowski sum of two meshes, which is itself another mesh. So it's like tracing a parabola onto a mesh. Because that's equivalent to doing mesh on mesh tracing. So like if I have two meshes and I want to know at what time do they collide, I can do the Minkowski sum of the two meshes. And what that is if you imagine the center of both objects, and then you keep one fixed and trace the other one over the entire surface of the other object, the surface that the center point traces out is a new mesh. And it's like both of them added together, a ballooned mesh. That's the Minkowski sum of the two meshes. And so if you like trace a parabola onto the Minkowski sum of the two meshes, that's the same as tracing a parabola on mesh to mesh. So that's how the collision works. So the Minkowski sum isn't computed in full. It's procedurally queried So where's the trait implementation? Here it is. Okay, mesh query. So what's a vertex? Where is this vertex by ID? And then what are the edges on this face? So like if we're on this face, there's 4 edges. It'll return that list. And so of course on a Minkowski sum, the face edges are like slightly different. There's maybe more. And there's like different cases. So it's like walking. Okay, how the algorithm works is you have a starting point, and then it projects that onto the surface of the mesh. And then as you move along the parabola, it traces the closest point along the surface and onto the edge, traces it along the edge. And then once it intersects with the parabola, you've collided. That's the entire algorithm here. It's called the face crawler algorithm. There it is. Next transition. So it's like, here's the algorithm right there. So it's like, what is the next transition? You're on a face, you're moving along, you hit an edge. Hit. No. Next. Next. And then it's like, oh, now I'm on an edge. What's the next transition? And then it moves along the edge. Oh, I move onto a face. Next. And then it goes, oh, the parabola intersected with the closest point. That's a hit. Or, we reached infinity. It's a miss. Very complicated, and there's a lot of stuff I have under my belt already. I went straight to all the hardest ideas, the most perfect ideas I had, trying to make it the best possible. Internals. I'll be right back. There's a lot going on here. I've covered a good chunk of the code in the past, 10, 20 minutes? Your questions have been just leading enough to send me off on a ramble, which I'm happy to do. Right, I was talking about visualizations. Right, so it's visualizing this. Really, it would be great to step these transitions one at a time and have a wireframe view of the Minkowski sum and watch it go and trace along the surface and then go, oh, that's wrong, and then fix it. I have hours and hours of stream VODs where I have my Minkowski sum meshes and I'm going, just trying to imagine all the different cases that are possible. It was really hard to make. Oh yeah, I wanted to make a remove the generics from the trait. Mesh query trait. What works. I mean, this is a little bit deep. This is a bit beyond what works, isn't it? This is I have a perfect idea. What if I was to implement it? What if it's it's like writing down every single what if and making it do that.